Hello everyone, welcome back. So now let's talk about some frictional rolling problems. Okay, so when we're analyzing the rolling motion of wheels, cylinders, discs, etc., it's not always known if that body rolls without slipping or if it slips as it rolls. Just think about it. If it's rolling without slipping, then it just moves forward perfectly. Friction is enough to hold this disc in place as it tries to pull forward. Everything's wonderful. Otherwise, this will spin out. It'll keep on moving forward probably, but it's spinning a lot more times than it needs to get that motion. So for this disk right here, the equations of motion we're going to see are going to be the following. We're going to have a pulling force pulling us forward. We're going to have a weight through the center of gravity. We're going to have a normal force pushing up from the ground, and we're going to have frictional force, which is going to be resisting the motion. And if we put our three equations in here, we see we got, okay, the pulling force minus the frictional force is going to be equal to our acceleration in the tangential direction. The normal force minus our weight is going to be equal to 0 because it's not going to accelerate upwards. And the frictional force times our radius is going to be equal to our angular acceleration times the mass of inertia. Now there are four unknowns in those three equations, which makes you kind of stuck. Okay, well, how do we find that fourth unknown? Well, the fourth equation is going to be either from the slip or non-slip condition of the disk. If it's slipping, you have one equation. If it's not slipping, you have another. So if it's not slipping, then you can say, okay, well, my tangential acceleration is going to be equal to my angular acceleration times the distance, so the radius, and that will be your fourth equation. Do not use this one though, okay? That doesn't work for this. There's a point where that can work, but it's not in every single problem. Now, if you were wrong, then you will get that the frictional force you would have needed will be actually more than or equal to the max frictional force. And in that case, this would be the mistake. In the second case, though, when you assume slipping, you say, okay, well, if I'm slipping, then our friction is going to be the kinetic friction, which is always the same. And the tangential acceleration will not be equal to the angular acceleration times the radius. So this would be my fourth equation. And this happens quite often. You'll see quite a few problems that ask or mention slipping. And this is the equation you should come to. So I think that's everything. Oh, no, we got some procedure for analysis. Let's talk it out. Let's go through it quick. A lot of this is the same thing as always. Get your coordinate system. Draw a kinetic diagram so you can see what direction it's accelerating, as well as what direction it's rotating. And then apply your three equations of motion. If there's four unknowns, then you have to think about your slip condition. Maybe you're going to use the no slip condition, maybe you're using the slip condition. Either one, make sure you're using the correct equation. And then check its validity. Check its validity. Make sure it actually works. If the frictional force that you need is more than or equal to the max kinetic or max static friction, then you've chosen the wrong condition. You should go with the slip condition. Be very careful that you're using these same directions the entire time. Be consistent. Okay, be consistent. And also remember that your frictional force is trying to oppose the motion. Okay, it's trying to oppose the motion. It's not always easy to visualize, but I guess the best way to describe it is just think about what friction is doing. Okay, what friction is doing, and you can go from there. Well, that's it for this time. So thank you all for listening, and I'll see you later as we try out a few problems. Have a great day.